We're going to use some algebra techniques in order to turn an equation of a parabola in factored form, where you're getting the x-intercept, into its standard form version, which will show you where the y-intercept is. So first off, this is just a multiplication. So we need to do a little primer on what these things mean. So if you have something written like this, 3 times 5, whenever you see two things pressed together like that, it is implying multiplication. So this bracket multiplied by that bracket, you can tell because they're just pushed together like that. So 3 times 5 would be 15. Okay. If you see something like this, now if you're thinking about it, 1 plus 4 is 5. So the answer to this thing has to be 15. I'm writing this way to show you how to handle a multiplication of two things in a bracket, because we're going to have to do that in a minute. What that's saying is that everything in this bracket that's separated by a plus or a minus, everything in there has to get tripled. So this 3 has to act on the 1, and it has to act on the 4, leaving that plus sign in the middle. Now if you fact check that, 3 times 1 is 3, 3 times 4 is 12, and 3 plus 12 is 15, which I already knew because I had already worked that out. So that worked. It got me the right answer. I could see that I had to multiply everything in here by what was out front. So if I try that same idea on something that looks like this, I just switched out a number for a letter. I can see that both of these things in this bracket need to be multiplied by 3. So 3 times x is 3x, and 3 times 4 is 12. So I don't have to simplify this, or I can't simplify this, because that has a letter and that does not. But I have successfully managed to multiply everything in that bracket by the thing in front. Okay, so what does it mean when you have something like this? Again, if you're thinking about it, 1 plus 2 is 3, and 1 plus 4 is 5. So this times this should give me 15 as an answer. I'm writing it like this, though, to show how you can scramble these four things together when you're doing the multiplication. So this is telling you that everything in this bracket has to be multiplied by everything in that bracket. So not just by 2, but by 1 as well. So the way you kind of hack through this is you pick something from the first bracket. I'm going to start with a 1, and you multiply it by something in this bracket. And then you multiply it by something else in that bracket. Then you pick something in this bracket and multiply it by something in that bracket. I think I'm writing this on my face. And you pick something in this bracket and multiply it by something else in that bracket. And then you ask yourself, have I done all of the combinations that are possible? Did I put the 1 with the 1? Yes. Did I put the 1 with the 4? Yes. Did I put the 2 with the 1? Yes. Did I get the 2 with the 4? Yes. Those are all the combinations of picking something from this bracket and something from that bracket and multiplying them together. Now, if I've done this correctly, I should get 15. So 1 times 1 is 1. 1 times 4 is 4. 2 times 1 is 2. 2 times 4 is 8. 1 and 4 is 5, 5 and 2 is 7, 7 and 8 is 15. So this method, or this technique of scrambling all those numbers around, does give you the correct answer. So what does it look like if I have a letter and a number, and a letter and a number? Well, pick something from this bracket. I'm going to start with the X and put it with something else from this bracket. Next. Take this thing again and put it with something else from that bracket. So those are all the combinations of pairing the X with something from this bracket. Now try getting all the pairings of the 2 with something in this bracket. So I need 2 and an X, and a 2 and a 4. Now that's a bit of a mess. X times X would be X squared. That's 4 X's. We usually just, as a grammar rule, write the number first. That's 2 X's, and 2 times 4 is 8. I've got 4 X's and 2 X's here, so I can add those together. It gives me X squared plus 6X plus 8. Now, looking at this thing, I started with something that looked like factored form, and I ended up with something that looked like standard form. So by doing this shuffling here, I'm able to take 2 brackets with 2 separate things in them and mash them all together to get just the squared, a linear term, and then a number with no variable attached at all. So I'm just going to clean this off here, and then we're going to try that one up in the top left corner. So I was given this parabola. It has an x-intercept at 1. This 1 would neutralize that, and at 7 should neutralize that. And I'm going to try and convert it to standard form using this multiplication technique. So pick something from this bracket. I choose the X. Put it with something in this bracket. I choose the other X. I did that. The only other combination would be to take this X here and put it with my -7. I'm just going to keep the negative in a bracket there so I can see that it still exists. And that is all the combinations of this X with everything in this bracket. So try with the -1 then. I'm going to put the -1 with an X. I'm going to put the -1 with a -7. Okay. X times X is X squared. Math grammar, usually write the number first. So -7 X's. A positive times a negative is a negative, so I can choose to write just one sign there. Subtract 1x, and a -1 times a -7 is a positive 8. Put these two things together. -7 minus 1 would be -8 x's. Hi, friends. -1 times -7 is positive 7. It's going to be a long day. There we go. Much better. Okay. So I started with something in factored form, and I ended up with something in standard form. Now, there's a little acronym floating out there. FOIL. You might hear somebody say that to expand these, you have to foil them. Foil either means like a thin aluminum sheet that you would wrap your food up in, or foil also means to like thwart something, right? It foiled your plans. In this case, you're not doing either of those things. Foil stands for first to, outside to, inside to, and last to. So if you look at how I did this, I took the first two things in both brackets and I multiplied them together. Then I took the outside two things, right, the one on the far left and the one on the far right, and I put them together. Then I took the inside two and put them together. And then I took the last two in each bracket and put them together. So this little acronym is just trying to help you make sure you don't miss any combinations. The other way to think about it is you end up generating 4 terms every time. And this function, right, this shape, a parabola, comes from something called quadratic functions. Right, so this thing here is a quadratic function. And if you look at that word, right, it starts with QAD. And in English, anyway, possibly I would guess many European languages or any languages that have Roman roots, that prefix there means 4, right? So if you have a function generating 4 bits, 1, 2, 3, 4, there they are. There are 4 combinations of these things. So either look at here, grab one from there, partner with that until you have all the possible combinations, or take this list here and do the first 2, the outside 2, the inside 2, the last 2, whichever way makes sense in your brain, as long as you're generating all 4 terms because it is a quadratic, and then you can collapse these 2 together because they are like terms. So that's what it happens if it's just 2 brackets. What happens if it has a negative up front? Okay, well, I'm just going to leave this negative alone for a minute. I'm going to do all this stuff first. So my first pair, x times x. My outside pair, x and a negative 9, would be negative 9x. 2 and an x, 2x. 2 times negative 9. If I clean that up a bit, x times x is x squared. Negative 9x's plus 2x's is negative 7x. 2 times negative 9 is negative 18. So I have done the expansion, right? I've done this FOIL thing, just ignoring this thing up front for a little while. Now that I've got it done, this here says that every single thing in that bracket has to be multiplied by negative 1. And there's a sort of a 1 hiding there. So I'm going to let that happen. Negative 1 times x squared would be negative 1x squared. Negative 1 times negative 7 would be 7. And negative 1 times negative 18 would be positive 18. So basically, I ignored this term in the front until I had all this done. And then I threw it into the bracket. So that's going to be the same if there's a number. So let's try y equals negative 3, x minus 4, x plus 5. So I'm gonna ignore this for a while. So I'm going to need to build a bracket to do my work in, while that sits sort of cold and lonely on the outside. My first 2 would be an x with an x. My outside 2 would be an x with a 5. My inside 2 would be a negative 4 with an x. And a negative 4 with a 5, like so. I'm going to clean that up. X times x is x squared. 5x minus 4x is 1x. Negative 4 times 5 is negative 20. So negative 3 times x squared is negative 3x squared. Negative 3 times 1x would be negative 3x. And negative 3 times negative 20 would be positive 60. So just like the last one, execute the FOIL stuff, and then once it's done and cleaned up, then you throw that front number in there to get your final answer in standard form. Now, it worked that way for a negative, it worked that way for a number, it's going to work that way for a fraction too, and you're going to take a deep breath and you're not going to panic, because I know fractions cause nosebleeds, but they're really just numbers, so we don't have to be scared of them. Okay, so just like before, I'm going to just keep that cold and alone sitting on the outside of the bracket while these things work together. My first two, x and x, my outside two, 10x, my inside two, 2x, and my last two, 2 times 10, which I'll just write that. There we go. Clean it up. X times x is x squared. 10 x's and 2 x's is 12 x's. 2 times 10 is 20. So this has been FOILed, or the multiplication has been done. Now I just need to throw the 1/3 on everything. So 1/3 of x squared. Not much I can do to that. 1/3 of 12x, and then 1/3 of 20. So that, I can't simplify that. Right? 1/3 x squared is as simple as that's going to get. Now here, 1 times 12 is 12, and 12 divided by 3 is 4. And it goes in cleanly, right? 12 divided by 3 goes evenly, and your answer is 4. So you might as well write it as 4x. So check that on your calculator if you're not sure. But 1 times 12 divided by 3 gives you 4. This one at the back, 1 times 20 divided by 3. 20 does not divide evenly by 3. So the closest one would be 18 or 21. So if you try this in your calculator, 1 times 20 divided by 3 should give you 6.66666 forever. If it doesn't go cleanly, just leave it as a fraction. So 1 times 20 would be 20 thirds. There you go. So if it's a negative or a whole number or a fraction up front, doesn't make a difference. You just let it hang out here for a bit while you do all the FOIL stuff. Once your FOIL is done, everybody gets this number in front. This one got the third, this one got the third, this one got the third. In the case where it's a fraction, sometimes those fractions will work themselves out to whole numbers, sometimes they will not. If it's a whole number and you recognize it, great, write it as a whole number. If it does not go, you're welcome to leave it as a fraction like that. It's actually preferred to leave it as 20 divided by 3 instead of 6.66666, because this has no rounding error. As soon as you try to make this a decimal, you're clipping it off at some point, and your equation isn't exactly what the original was. So there you go. Factor to standard. Do your FOIL first, then apply the number out front.